Back to our second video on double linked list. In this video we are going to continue connecting our new nodes and we're going to jump right into it. So I'm going to draw really quick what's going to happen in this video. So of course the second time around that we call the create node function is going to go ahead and create a new node, and it's going to also go ahead and initialize it as well. So that's what I'm going to do here. So previous next pointer to a node, and let's say the information inside here is 2, and of course this is going to be initialized to null. But what we're going to try to make happen is connect the previous node to our new node here. So really what's going to happen in here is going to be a connection from our first node to our second node right here through the next. The previous node is always going to be the newest node right here, and that's going to be more clear in a little bit, but for right now we're just going to go ahead and connect this right here. And also we now have to connect the previous of this node right here, which of course is going to be this one right here. And the next of this node, since it's a circular linked list, is actually going to be the first node, which is going to be whatever root is pointing to. In this case is going to be this node right here. Okay, so now let's say we want to insert another node into this linked list. So what we're going to do is, of course, the function is going to get called one more time. So we're going to go ahead and call the create node function. Is going to go ahead and create a new node again with the same information as the previous one. This information was defined in the structure as we did in the first video, and let's say the information inside this one is 3. So now let's see what needs to happen. So the previous of this node is going to be the node containing number 2. The next of this node is going to be whatever root is pointing to, so it's going to be this one right here. And we're going to need to move some of these connections right here, of course, to include this node into our linked list. So I'm going to go ahead and let's see, first we are going to say connect this node to whatever root is pointing to. So what we're going to go ahead and say is whatever root is pointing to is going to be the next of our new node right here. As you can see, we haven't gotten rid of what this is pointing to yet. Both of this node and this node at this point in time, both of them, their next is pointing to our first node, and that will change in a little bit. Now we don't have a way to access this yet because we don't have a direct pointer to here. We'll have to access it through a variable, and that's what we actually created, the previous node variable. So I'm just going to go ahead and call it priv. And just gonna say priv.end, for example, for previous node, and it's gonna point there. So that's gonna help us basically go through the linked list to get to this point right here. So we can point to previous here. Also, another thing that we're gonna do is say that we want to connect whatever root is pointing to, which in this case is always gonna be the first node, to our current node right here. So in this case, when we do this action, the previous node in here is going to point to our newest node right here. So now this node is connected to our last node right here. So the previous of our first node is going to be our current node. And of course, this is going to disappear. The connection between previous node and this node right here is going to disappear. So I'm going to go ahead and erase this, and you can just go ahead and do that. Delete that connection between those two nodes right there. And oh, I deleted the wrong one. Okay, so it's actually this right here, and I'm gonna go ahead and reconnect this right here. This will change in a little bit, but as for right now, this is still true. This is still happening. Gonna go ahead and correct this a little bit. There we go. Okay, so we are going to connect what is the next of the node to of our new node, the previous of our new node to our previous node. So the way that we're going to do that is iterating this right here, which is also going to be pointing to root. So it's going to be pointing to whatever root it's pointing to. We're going to go iterate it. And the way that we're going to do this is saying if the next of this node right here, of what our previous node is pointing to, is the root, then we know we're at the last node. So in this case, for example, the previous node next, which is this one, is no root. So we are going to go ahead and move this previous node right here. We're going to go ahead and move that from here. And actually, I'm going to, delete that right there. And it's going to get moved here. So now I'm just going to call it PN, previous node right here. And it's going to be pointing just right here. So because this, when it was pointing here, this one wasn't root, then it gets moved. And I will explain how to do this. Then we're going to go ahead and check again if the previous node next is root. In this case, it is. So the previous node next is what root is pointing to. So we're going to go ahead and stop there. So now we have a reference, direct reference to this node right here. In this case, what we're going to do is actually say that our previous node, our pointer is going to go ahead and point to here, to whatever previous node is pointing to. So in our current node, which is this one right here, on our current node, the previous node pointer to that is going to point to previous node, and that way we're going to go ahead and connect that as well. And since we have a reference to previous node now, we can go ahead and also say previous node next is going to go ahead and connect to the node. So this connection is going to happen right here. And of course, this connection now is going to not happen anymore because we just changed that. So that will disappear as well. And delete that right there. And okay, so that will disappear. So as you can see here, we are fully connected in this linked list right here. We have our first node that is connected to our second node that is connected to our third node. And the same thing, the previous node of this node is connected to this one, the previous node of this node is connected to this one, and the same thing here. So we have a circular. So what we're going to do right now is we're going to go ahead and start coding what we need to do. So in this case, let's delete all this right here. And let's see, go back to the point where we were before. And just say no. And no. Okay, so the first thing that we're going to do, of course, is call this function. It will not go to the if statement, as I said before, it will go to this. And at this point, as we can see here, the node was already created, pointing to null as well. So let's go ahead and draw that out. And we have number 2. In this case, just as an example, and both of them will point to null. Both of them will point to null. There we go. And node is, this is our current node right here. So this is our node. Okay, so the first thing that we want to do here is connect the pointer next to our root right here. So what we're going to do is connect this right here to here. And okay, so we are gonna go ahead and do just that right now. We are gonna go ahead and have a reference to the node next, which is going to be what root is pointing to. So in this case, if you can see in here, root is pointing to this node, and this node is connecting its next to that. So now we are gonna go ahead and say whatever root's next is pointing to, previous is pointing to, is not going to be null anymore, is going to be this right here. So we're going to go ahead and delete null and what is pointing to our previous, and go ahead and connect it to our new node. So this is our next step right here, and the way that this is going to happen is saying that whatever our root is pointing to, and the previous of that is going to point to our node. Okay, so that's going to happen like that. So the next thing that we're going to have to do is check if this is null. So in this case it's null, so we are going to connect it in here. If it's not null, we'll have to move whatever this is to here to check if this is null or if it's pointing to root to know where we're standing. So in this case, we're gonna need to use our previous node right here, which we declare here, and it's pointing to root. It contains a pointer to root, so the pointer is going to be this one right here. So what we're gonna check for is if previous node next is null, we are gonna go ahead and connect it to this new node. So the way that we're gonna do that, we're gonna use an if statement right here, and we are gonna say if previous node next is equal to null, we are going to connect it to this node right here. So previous node will next will get our node right here. So what just happened was this connection right here. So I'm gonna go ahead and make that connection. So because that was null, we're gonna go ahead and connect it. So that connection just happened right there. That's what we just did. So what we also need to do is connect our previous node to here. So that's really simple. What we're gonna do is dereference this from null and go ahead and do that connection right there. So this is gonna be done really simply. Outside this if statement, we're gonna go ahead and say node previous is gonna get whatever the previous node is pointing to. And I think I forgot an E right there. There you go. Previous node is pointing to. So in this case, because previous node is pointing here, our node previous is going to connect to previous node, which is going to be that one right there. So this just happened. So now in the example at the beginning of this video, I was explaining that we also need to have another node here, for example, just to add it to our list. So this will be the third time our create node function will get called. We say, let's put 3 inside it, and previous node right there, and this is going to be null, and null. This is just creating our node right here, which again will happen right here. Okay, so let's see how we can add this node into here. So we have So we won't go into this statement, if statement, because root is no null, as we can see in here. So we'll go into the else statement. So let's read here what happens. So node next will equal root. So what will happen here is this, of course, node is not pointing there anymore, but this is our node right now. That's our node right here. So we're going to say node next gets root. So we're going to go ahead and connect that. So node next will not equal null anymore, but will equal root. So we go right there. So that's what happens there. Then we're saying root previous, or whatever root is pointing to previous, is our node. So root is pointing to this node. So the previous of this node is not going to be this anymore, but is going to be, so let me remove this reference right here to that. And that right there. Okay, so it's actually going to go here. It's actually going to go here. So that's what's happening here. So now, if previous node next is null, go in here. But as we can see here, previous node next is not null, is this node right here. So what we're going to need to do is advance, move this previous node to this node right here. To do that, we're going to need a while loop. So the way that we're going to do that is the following. Okay, so our while loop is actually going to go inside an else right here. So while pointer, previous node next does not equal what root is pointing to, because we have a reference to where root is pointing to. We are going to go ahead and move this previous node to here. So the way that we do that is previous node will get whatever previous node next is pointing to. So what happened here, once we go through here, is going to say, is previous node next what root is pointing to? In this case, is not. So we are going to get rid of this right here and say that previous node gets whatever previous node next was pointing to, so it's right here. So we're gonna go ahead through the loop one more time, and we're gonna say, so previous node next, what that is pointing to is actually root this time, so we will stop here for this previous node, because this statement became false. So we are gonna jump outside our while loop right here and say that previous node next will get our new node right here. So previous node next will get our node. So what just happened here was this connection right here. So previous node next will get our new node, and of course the reference to this first node right here, it's not happening anymore. So that can disappear right there. So that reference is gone. Alright, so as you can see here, the only thing that is left is connect the node previous here to a previous node. So we are gonna go ahead and do that as well. And that is actually happening here. As we can see, node previous, which is going to be node previous, is going to connect to previous node. So we already did that. And that just happened in our code right now. Alright, so we're gonna go ahead and connect it. So as we can see, everything is connected as it should. The only thing that we need here is to actually specify what this function is going to return upon success. Because as you remember, this is an int function. It's going to be expecting to be returning a integer. So at this point, we're just going to go ahead and say return, and we're going to go ahead and return 0. Because we know if we get to this point, everything was successful. The only point that this program can fail at this point will be if there's not enough memory, and in this case, we'll return 1. So that is it for this video. In the next video, we're gonna go ahead and compile this program, make sure it works, and also write another function to print everything out. So the first time we call a function to print things, it should be 1, 2, and 3. So this is what we're gonna work in our next video, getting this linked list to print these numbers, basically just traversing through the linked list and stopping here, so we won't create an infinite loop. Okay, so I'll see you in the next one.